Exercise 10. Write a system of inequalities whose solution set is the shaded region. Okay, looking at this shaded region, well, it's convex and it has linear boundaries. So, observe that. Convex has linear boundaries. And once you've noticed that, this means you know you can do this with a system of linear inequalities. Will work. Okay, well, let's see here. We are going to have to create this as the intersection of 4 half planes. Okay, we have some boundary lines here. Perhaps we could label them L1, L sub 2, L sub 3, and L sub 4. Alright, let's begin by creating our first half plane whose boundary is L1. L1, first of all, what about the equation of this boundary line? See, it's a horizontal line, so we know to think of horizontal form, which is a y equal to a constant type of an equation. Here, looks like we need to hold the y at the value of -2. Now, what kind of inequality do we want? We need a half plane that goes all below this boundary line. That being the case, we're thinking about y less than, how about an equal sign? Dashed line. No, the equalities are not to be a solution of this. Simply y less than -2 is what we want there. Okay, let's go to L2. As our boundary line goes, it's a vertical line. Okay, so we're thinking about vertical form comes to mind, and that is the x equals to constant type of an equation. In the case here, the x is held to being -1. So our boundary line would be x equal to -1. Now we need to create an inequality whose half plane goes over here. Alright, looks like we need to have the x being less than, to the left of -1, and it's a dashed line here, so do not put an equality. We don't want those to be solutions. It's strictly x less than -1. Okay, let's go to L3. L3, okay, this line is horizontal, so we're back to considering the horizontal form for our basis. We have that known to be y equal to a constant. In this case, the y is held as being -5 for its value. Now we want to get a half plane all lying above this boundary line. So that means y greater than solid line or equals to -5. Okay, let's go to L4 here, this boundary line. First, let's kind of create its equation. Let's see, we have this sloped line. It's got, we have 2 points that are known to it. Alright, one of our choices would be to work off of point slope form. Okay, what's that? That's the y minus y1 equals m times x minus x1 form there. So we need the slope m to fill out this form. M equals, okay, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, if you know 2 specific points. And we do. Alright, I always choose the right hand point to be the sub 2 and the left to be the sub 1. Doesn't matter which way you do it though. And so we'll have -5 minus a -2. Minus -2 is really plus 2. And then we have -5 minusing -7. which really is plus 7. Okay, let's work out the arithmetic here. We're going to have negative 3 over 2. Now, checking the work here, the arithmetic, this line, rather, it goes downhill as you ride along it left to right. That's the basis for a negative slope. And it's also more steep than the diagonally line at negative 45 degrees, so the slope should also be a little more negative than negative 1, which it is. So I'm feeling confident about the calculation here. Keep going. Now, we can choose either point to serve as x1, y1. Maybe we'll choose negative 5, negative 5. This would lead to y minus negative 5. All right, that's y plus 5 equals slope x minus negative 5. That would be x plus 5. Okay, maybe expand this out a little bit here. Now we could add 5 to both sides. And 15 halves, let's see, 5 is 10 halves, so that would give us negative 15 halves plus 10 halves. Minus 5 halves is left over. To check our work here, we could look at L4 and decide that the slope looks about right. Negative 5 halves for y-intercept. Ooh, wait, inconsistent. Look at that. Negative 5 halves, that's only negative 2.5 that's here. This line does not have that kind of y-intercept. So we have an inconsistency here. Let's see if we can find it. We back up a bit. We maybe start here. Negative 3 halves x. Okay. And then it was 3 by 5. Negative 15 halves. Okay. This step here. Oh, we were supposed to subtract 5 from both sides. Okay. So it's really negative 15 halves minus 10 halves. That's negative 25 halves. Now, that's negative 12.5. That y-intercept looks consistent with the graph. Okay, caught an error there. It looks like we're back on track. Now, how about the inequality? We need to be above this line L4 for the half plane, so that leads us to a y greater than solid line or equals to minus 3 halves x minus 25 over 2. Okay, let's put together our system here, our answer. So we need to put all together y less than negative 2, y greater than or equal to negative 5, x less than negative 1, and y greater than or equal to negative 3 halves x minus 25 halves. Okay, last thing we might want to do is kind of check things over here. Check. Okay, let's find a point that's clearly in this shaded region. So perhaps we could go down 1, 2, 3, negative 3, negative 3, negative 3, clearly in the region. So it's a solution. So let's substitute it into each inequality. Now, it's got to make every single one of these true. Here we go. The first one we got negative 3 less than negative 2. True. Second one, we would have a negative 3 greater than or equal to negative 5. True. Third one, negative 3 less than negative 1. True. And lastly, negative 3 greater than or equal to negative 3 halves negative 3 minus 25 over 2. Let's see, this right-hand side, this would be 9 halves, subtract 25 halves. Let's see, that would be negative 16 halves. And let's see, negative 16 halves, that's negative 8. So how about negative 3 being greater than or equal to negative 8? True. Okay, and that looks like our check is successfully gone along, and so the system looks good. Okay, exercise 12. Write a system of inequalities whose solution set is the shaded region. This shaded region, it's got linear boundaries and it's convex. Good. So, observe the region is convex and has linear boundaries. This implies that a system of linear inequalities will work. So in other words, we imagine this as being the intersection of 4 half planes. This one, this one, this one, and forgot this one. Okay, well, we're going to need boundary lines to get these half planes described to begin with. So maybe we start labeling the boundary lines here. L1, L sub 2, L sub 3, and L sub 4. Okay, let's begin with the inequality with L1 as the boundary line. First we need L1 itself, the equation. Okay, it's time for horizontal form. That means y equal to a constant. In this case, that constant is y is equal to 0, in fact. Okay, now, as far as what to do with the inequality here, since we have a horizontal line, we can think in terms of we need to be below it for the half plane. So we are looking at y less than solid line or equal to 0. Okay, let's go on to L2 and get the inequality whose boundary line is L2. Let's see. This information available here, we have a couple of intercepts available. So we could use intercept form, or we could use slope-intercept form. Either way. Okay, let's try slope-intercept form in this case. What is that form? That's y equals mx plus b. Okay. M is equal to the, you could do it rise over run, think of it that way. Now as you go from here to here, the rise is down 1, 2, 3, 4. The run is over 1. We're looking at a negative 4 over 1, or a negative 4 for a slope there. Okay, now the y-intercept is here. It's negative 4. So this gives us a y equals 2, negative 4x minus 4. Okay, now that's the boundary line. What about the inequality? Since it's in this form, y equals to mx plus b, we can think in terms of, do we want to be above or below the line? We want our half plane to be below the line. So this gives rise to y less than solid line or equals to negative 4x minus 4. Okay, time for the inequality whose boundary line is L3. L3, what to do about the equation of that line? Well, it's time for a vertical form for the basis of our thinking. And what's vertical form? That's x equals to a constant. Now, what about in this case? Well, x is actually equal to 0 in this situation. There's our boundary line. Now, how about the inequality? Alright, since we want to be to the left of this, we need to have x less than, boundary line is solid, or equals to. Okay, let's go on to L4. Get the inequality whose boundary line is L4. Alright, I suppose for the sake of variety, this time the information also could be used in one of two forms, very conveniently, either intercept form or slope-intercept form. This time, let's try using the intercept form for variety. The form you use is really a personal preference almost in many cases, and forms are something you need to memorize. You may not want to memorize intercept form, but if you do, it can be very quick in certain situations, like this here. The form, by the way, is x over a plus y over b equals 1. A is the x-intercept, y is the b, and b is the y-intercept. Okay, so in this case here, we'd have x over negative 9 plus y over negative 6 equals 1. Now, these negative signs, maybe we don't want to have so many negative signs, and maybe we want to clear the fractions too, so we can multiply both sides by, let's see, negative 18. Okay, let's do that. 18 here would give a cancellation and leave us with positive 2x's and then plus 3y's equaling negative 18. Okay, now as an inequality, what do we want here? Well, we would like to see 0, 0 make the inequality true. If we put 0, 0 in here, 0, negative 18, well, 0 is greater than 18. So we're thinking about choosing 2x plus 3y greater than solid line or equals to negative 18. Okay, there's an inequality that corresponds to L4 as its boundary line. Let's put our system all together here. Okay, we have y less than or equal to 0. We also include y less than or equal to negative 4x minus 4. We also include x less than or equal to 0. We also include 2x plus 3y greater than or equal to negative 18. We want our final conclusive answer to kind of jump off the page, hence the clouded encircling here. Now, could have made a mistake along the way here for sure. So let's see here. Let's grab a point that's in our solution set and maybe makes the arithmetic fairly easy to work with. How about negative 2, negative 2? Clearly in the region here. Okay, negative 2 is in the shaded region. Alright, that makes it a solution. So, let's try substituting into each inequality. See what happens here. Now we have to get everything true, or else there's an error. The first one, y less than 0, y, that's negative 2 in this case, less than or equal to 0. What do we think about that? Let's think of the number line. Negative 2 is indeed to the left of 0. True it is. Second one, y, negative 2 less than or equal to negative 4 times x is negative 2 minus 4. what does this inequality say when simplified? The right-hand side is actually a positive 8 minus 4, 4. It's negative 2. Less than or equal to 4? True. Okay. Third inequality, x, that is negative 2, less than or equal to 0? True. Final inequality, 2 times x is negative 2, plus 3 times y is negative 2. How about that being greater than or equal to negative 18? Okay, this left-hand side is a negative 4 plus a negative 6. That's negative 10. Negative 10 greater than or equal to negative 18? Think of the number line. Negative 10 is indeed to the right of negative 18. This is true. Okay, so this does pass our check. Looks pretty good. Exercise 14. Write a system of inequalities whose solution set is the shaded region. Okay, this shaded region, a couple of properties it has that are important to us. One, it's convex. Two, it has all linear boundaries. Okay, so observe the region is convex and has all linear boundaries. Okay, what that tells us is that a system of linear inequalities can work here. Will work. The basic idea is we will create this as an intersection of 4 half planes. Okay. Well, the boundary lines are going to be important to us here. So maybe to keep our work clear to someone reading it, we can label these. We'll call this line 1. We'll call this line 2. This line 3, and this line 4. Okay, starting here with line 1, let's see, how will we get this equation of this boundary line? Well, we have these 2 points here you might consider. Point-slope form. Remember, that is y minus y1 equal to m times x minus x1. Okay, we need the slope m. M will equal, we can use the y sub 2 minus y sub 1 over x sub 2 over x minus x sub 1 formulation for slope, and let's call this one the second point, this the first point. So now we have 4 minus 7 over 10 minus 5. Let's see, negative 3/5. Alright, negative slope, the line should go downhill, and not so steeply downhill as a negative 1, a negative 45-degree angle, which is indeed the case. Okay, calculation is consistent so far. Let's form up the equation using our form. We'll choose this point to be the x1, y1 in this case, and now we have y minus 7 equal to m negative 3/5 x minus 5. Okay, maybe we'd like to have this actually be rewritten in slope-intercept form, and so let's expand here. This is minus 3/5 x, then plus, let's see, 5's cancel 3. Alright, now we can add 7 to both sides. We've got y equal to negative 3/5 x plus 10. And let's check that briefly. So the slope negative 3/5. Okay. This y-intercept of positive 10. Alright, we may not actually see it, but as we sort of extrapolate out here, positive 10 seems consistent with this graph. So we keep going. Now, we need the inequality that has this half plane down here. In this case, we can think in terms of, do we want above or below the line? We want below the line. So now we're thinking y. Let's see. It's a solid boundary line, so it's less than or equal to negative 3/5 x plus 10. Okay, there's L1. Let's go to L2. And here, what could we do? We need this boundary line. Alright, 2 points. Once again, we could consider point slope form. Y minus y1 equal m times x minus x1. Let's get that slope. M will equal, as before, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I always call the right-hand point the sub 2 point to make the denominator positive. Doesn't matter though. But here we go. 4 minus 1 over 10 minus 8. Looks like 3 over 2. Now this has a positive slope more than 1, so it should be more steep than the 45-degree angle line. It seems to be the case. This looks good. Keep going. Now, forming the equation, suppose we select this point as the simpler of the two. We have y minus 1 equals to 3/2 x minus 8. Okay, maybe we expand this right-hand side. 3/2 x minus, let's see, factor of 2 cancels, leaving us with 4 by 3/12. Okay, add 1 to both sides. Y equals 2 3/2 x minus 11. Does that look reasonable? 3/2 for the slope, yeah, positive and more than the 45-degree angle line. Okay, negative 11 for y-intercept. Just a visual extrapolation. That seems reasonable based on our graph here. Okay, we'll proceed and now form the desired inequality. Let's see, we want to be above this line. Since it's in the slope-intercept form, we can think in terms of, do we want above or below the line? And here it's above the line we want. Also, this is dashed, so we don't want to include equality, just greater than. Okay, so we're looking at y greater than 3/2 x minus 11. Okay, now let's go to the inequality that's going to be based on L3. Alright, once again, the conditions are we have these 2 points here, so we're back to considering point slope form, which is the y minus y1 equals m times x minus x1. Okay, how about m? As before, we can go with the change in y over change in x between these 2 points. That could be 1 minus 3 over 8 minus 2. Let's see, that's negative 2 over 6, known as negative 1/3. So this line should be kind of going a little bit downhill as we ride along it left to right to match the negative 1/3 slope. That's good. Alright, let's form up the equation then. We'll choose this to be the point on which we base this. So this means y minus 3 equal to negative 1/3 x minus 2. Okay, let's expand this right-hand side. This is negative 1/3 x plus 2/3. Now let's subtract 3 from both sides. Y equals to negative 1/3 x. Okay, 2/3 minus 3, that's minus 9/3. That's a net effect of minus 7/3. Let's look for graphic consistency here. Let's see, that's negative 2 1/3 for a y-intercept. Here's L3. The y-intercept is, wait a minute. This does not look right. The y-intercept here is up here. It's like close to 4. Okay, so we don't like this right now. Let's review it. Go back to here. We like the slope. Let's look at what we have here. Y minus y1, y minus 3, equal to m x minus x1. Okay, that looked good. And it equal to 1/3, negative 1/3 x, and then the plus 2/3. Then we were supposed to add 3 to both sides. Okay, so this is the 9/3 and 2/3 added is 11/3. Hang on. Plus 11/3. Okay, so now there's how some graphic consistency has rescued us. 11/3, that's getting close to 12/3, close to 4, and the y-intercept here looks indeed a little bit close to 4. Now things look on track. Okay, now as far as L3 goes, what about the inequality that we need here? Alright, we need to be above the line in this case, so this leads us to y greater than. It's a solid line, or equal to negative 1/3 x plus 11/3. Okay, let's go to L4. Alright, it's sitting here. It's similar to the other three situations where we have these 2 points. Maybe we consider the point slope form. Once again, y minus y1 equals m times x minus x1, our basis for thinking of this, and our m will equal, okay, these 2 points, the change in y, 7 minus 3, over the change in x, 5 minus 2. Okay, so let's see, that will be 4 over 3. Does that look like a positive 4/3 sloping line? Yeah, I think it is. It's uphill as we write it from left to right, and it looks a bit more steep than the 45-degree line. So this looks good. Let's continue on to writing the equation. We'll call this the point of the point slope form, leaving us with y minus 3 equal to 4/3 x minus 2. Let's expand this right-hand side. 4/3 x, let's see, minus 8/3. Okay, now let's go ahead and add 3 to both sides. Y will equal 4/3 x. Okay, 3, that's 9/3. 9/3 added to negative 8/3 is a net effect of plus 1/3. Okay, let's see if we like that. The y-intercept here does indeed look like about positive 1/3. Things are looking good. Now we need the corresponding inequality. From here, we can think in terms of needing this to be below the L4 line. So our half plane becomes y dashed line only less than 4/3 x plus 1/3. Okay. Now we're finally ready to write our system. Looks like it'll be the half plane derived from L1 as the boundary line. So we've got the y less than or equal to negative 3/5 x plus 10. The inequality based on L2 as its boundary line is here. Y greater than 3/2 x minus 11. The half plane whose boundary is L3, that's here. Negative y greater than or equal to negative 1/3 x plus 11/3. And fourthly, the half plane whose boundary is L4, and that is a y less than 4/3 x plus 1/3. Alright, now let's give this one check over before we walk away from this. Okay, so as our check, let's take a point that's clearly in the solution set here. Okay, perhaps we choose 8, 2. That's surely in the shaded region. Okay, so 8, 2 is in the shaded region, and that tells us that 8, 2 is a solution. Okay, so let's try substituting into each inequality. Let's see what happens here. Okay, the first one, 2 less than or equal to negative 3/5 times x is 8 plus 10. Let's see if we can do this with mental arithmetic here. So here we have negative 20. Okay, let's just work out this side here. This is negative 24 over 5. And plus you'd have 50 over 5. Thinking about 50ths here. This adds up to 26 fifths. Okay, 5 and a fifth. As far as being greater or equal to 2 goes, we're looking at true. Okay, let's go to the second inequality. Okay, y is 2. 2, how about that being greater than 3/2 x is 8 minus 11. Okay, here cancel on the 2 and the 8. That's 4 by 3 is 12. 12 minus 11. It's 1. 2 greater than 1? True. Okay, third inequality. 2 substitutes for y. How about that being greater or equal to negative 1/3 x is 8 and plus 11/3. Okay, let's work out this right-hand side a bit here. This is negative 8/3 plus 11/3. Okay, that's going to be a net effect of 3/3, known as 1. 2 greater or equal to 1? True. Okay, one more to check. It's looking good so far. 2 for y. Is that less than 4/3 x plus 1/3? Okay, let's work out this right-hand side a little bit. This is actually 4 by 8, 32/3 plus 1 more third. Okay, so now we're up to 33/3, which is known as 11. 11 greater than 2? Of course it is. Gives us true statement there. Alright, this seems to be working out pretty well for a check. Looks like it's a pretty good solution. Exercise 16. How does the indicated region differ from the indicated regions of exercises 9 through 14? Alright, so we have this region here. Well, let's take a quick look back at exercises 9 through 14. Their regions. Okay, here is the region from exercise 9, 10, 11, 12, 13, 14. What about these regions? They're all convex, right? Convex. Bulging outwards, roughly defined, or If any two points are in the region, so is the line segment connecting them. Go backwards, take a look again. Here's 14, 13, 12. See? Convex. Pick any 2 points you like. Connect them with a line segment. The line segment lies within the region also. There's 11, 10, and 9. Okay. Now, if we take a look at this indicated region here, you'll notice it's not bulging outwards, convex. It in fact has an indentation, concave. Or more mathematically, there are 2 points, for instance, here and there. If I connect those two with a straight line segment, the line segment would not lie within the region. Okay, so this indicated region is concave as a result of that. So the indicated region is concave. The indicated regions from exercises numbers 9 through 14 were all convex. Okay, part B. Is it possible to write a single system of linear inequalities whose solution set is the indicated region? No. A system of linear inequalities always has a convex region, or an empty set. Okay, so, no. A system of linear inequalities always has a convex solution set. Convex, okay, or empty, no solutions whatsoever, but okay. Just to elaborate a little further, if you were really intent on describing this with inequalities, you could divide this into a couple of pair of regions, which each of which is convex, and proceed from there. So, for example, you could maybe extend this boundary line up like this, and then you have a like that, and now you can have this being R1 and this being R2, and then you can go along and say that the region, the indicated region, is equal to R1 union R2. Now, R1, you could describe that with a set of a system of linear inequalities. Solution set to a system of inequalities linear, and R2 would also be a solution set to a system of linear inequalities. So you have these two systems of linear inequalities, then you need to put the word or between these two, and that would at least outline a strategy that you could use to create this kind of region using union of systems of linear equations. Okay.